So can we please have a very warm welcome for our next presenter, API Metrics.
Hello, everybody. Thank you for having me here. As you can tell, I'm Nick Denny. I'm VP of Engineering at API Metrics. And as you can tell from my accent, we're a Seattle-based company. No, seriously, our office is around the corner. So let me take you way back. The year was 2012. I was working in my old startup, and we were doing mobile apps. And we kept going to hackathons, some for marketing, some to help out, some just to try and win stuff. And we noticed that the winners always had a nice, pretty-looking app, but it never actually worked. It never did anything. That's because they were calling, they never called the APIs. So here's me and my co-founder Dave hacking away, and it's, and as you can tell, deep in thought, because the point is, APIs are hard. That was happened to us. The problem is, especially with mobile, you have to handle the authentication, the asynchronous. It's a lot of work. And we were talking to the organizers, and they were seeing this too, and they wanted people to use their APIs. And the problem was, because nobody's using them, and when they heard back, anecdotally, it was like, oh, it was broken. And they were like, but they took to the dev team, and the dev team said, no, it's fine, it's working. And we thought, surely there's a tool to work to find out who's right here. And so, but APIs were kind of new, and RESTful APIs were new in the marketplace, so none of the tools really worked. So what we thought we really need was something that would make structured API calls, see how they worked. It basically a pingdom, but for APIs. API Metrics is born. So what we do is we give you a simple web form, and you can set up an API call, and then when it's set up, you can set it running, and you can set it running from all around the world in various different deployments. And by doing this, what we do is we make the call, record what we sent, record what you got back, record how long it took, and we see whether it worked and whether what you got back is what you expected. And that's the most important thing, because unlike some products out there, like Pingdom, 200 doesn't always mean OK. The content is not always right. So we're making these calls, and the point was that because we have all this data, we can see what's going on a lot quicker than you can, because if you've got logs, maybe there's so many logs you can't find the problems. Or maybe you've got an API call, and it's for, say, expense reports, and everybody submits their report on Friday. What happens and if the API breaks on Tuesday? Nobody's hitting that API, so your logs are never going to see anything. So if it breaks on Tuesday and suddenly you get called on Friday because it's been broken for days but nobody found out, you're going to have to work the weekend, and that's no fun. Any Amazon employees here, I'll explain the weekend later, that's fine. So we got all these data. So we draw you pretty graphs. Managers love pretty graphs. This is just the raw latency graph. As you can see, it's very peaky, but a lot of the calls are in the standard deviation, so that's good. But as you can, there's a few really long calls, so that's not so good. And we also analyze it in a different way. This is showing sort of the histogram, so it's showing the frequency of those return values. So as you see, most things are near the right-hand side here. Left-hand side for you. But it's got a kind of long tail, so that's something I'd want to look at. So as well as all these graphs for individual APIs, you can combine them into reports. And yes, your manager loves a report, so it's all good to have. So here we have some popular public APIs that we've been running for years. This is July's data. As you can see, nobody's perfect in the screen. And the one thing I want to take away from this is that oh, hello. Some of the maximum pass latency. So these are calls that worked, but they were very slow. There's one that's 27 seconds, another 22, another 34. So if your users are using this, you better hope they're patient, or you've got some kind of, your UI can handle your API you're using not being quick enough. And I can tell you, these are all from our default location, which is a California-based server. But if you're running from Japan, and you're calling an East Coast server, or even a West Coast server, it's really, really slow. It's up to a second. I'm pretty sure that The Trans-Pacific Internet connection is based on cutting-edge string and CAN technology. So we have all this data, and because we're running in lots of locations, we're actually running in lots of different clouds too. So if I give you this is from, we have a report out from last month that compares different clouds and calling each other. And so this, the takeaway from this is that Google is not in the same place as Azure and AWS, but Azure to AWS and vice versa is really quick. So that was a surprising answer. So this is kind of the fun, interesting stuff we get out of our data. And so we're APmetrics. Thank you. So questions, I guess. We're a SaaS service, so it's basically the number of API calls you make is how we charge. Not currently. Very soon we're going to have Swagger and RAML and that importing things like that. That's currently in dev sprint right now. So yeah. Oh.
Are your customers primarily developers that want to test their own APIs to see if they're having good uptime, or people that are writing code against APIs and trying to see?
I mean, it's a bit of both. We're happy to do either. Generally, it's been people checking. We see ourselves a bit like if you've got an SLA, we're an independent third party, so you can verify you're meeting your SLA, or if somebody's promised you an SLA, whether they're breaking it. So almost insurance. SLA insurance is almost our job. Okay, thank you.